Hello, I'm Ojas from Team TerraBats 14525, one of the programmers. I worked on Vision this year for the Decode season, and I'll be going on how to implement it yourselves to detect artifacts in the loading zone based on regions and areas. So let's create variables to detect the region of interest in the loading zone. We're gonna have, from the center of the screen, we're gonna have 35% above the center of the screen will be the top region of interest zone. The right will be 65% of the right half of the screen, and the bottom will be negative 0.65 or 65%. We're going to be using left and right as the same, so I declared only right as one. Then we initiate the image constants, which are the image width. In my case, we're using a Logitech C270, and the image width is 640 pixels, and then the middle is just divided by 2. Now we initiate the loading zone constants. Here, we're going to define the region of interest or ROI widths, and then we basically figure out the region of interest width is going to be the middle times the right, so 65% of the width, half of the width times 2, so you get the width of the region of interest. Then you divide this by 4 to have a fourth of the region of interest. Then you find the distance from the left to figure out the left bound, the middle bound, and the right bound to compare our artifacts' locations with. Then we initiate the region areas and list lengths. Here we define the region, which is going to be our variable, as -1 initially because we don't know where the region is. The 0 will be for left, 1 for middle, and 2 for right. Then we have all these region areas. For each region, there's going to be 4 regions total. And then for that area, it's going to be the purple region for the purple artifacts, 4 of them. And then for the green. And then there's going to be a biggest max area or variables, and then the list length variables. Then we'll declare the camera that's connected to the control hub as the webcam. Then we'll create a purple blob locator. What does this do? This is a color blob locator processor. Basically, it's a processor that can figure out, based on the image of a vision portal, and given a camera, can figure out where the artifacts are located, and it can detect and create a contour around the artifacts on the image. So as you can see, it's going to set a target color range, and this artifact purple, which is a scalar, which is a color range between these two values that indicate a purple artifact. We're going to set the contour mode to external only because imagine the artifact, there's small little holes in it, and we don't want those. We only want the external contour. Set the image of region of interest as these that we defined at the top. We do negative right because, again, we don't have the left. We set draw contours as true because we want to see them on the image. We set the box fit color to 0 because we don't want rectangles to be drawn. We want the circle to be drawn, which we can set the fit color here as yellow. We set the blur size to ensure these transitions between the different colors are in the image are smooth due to maybe bitrate compression or bandwidth limitations in the wire. Then we're going to dilate and erode to ensure that we can expand any blobs again to fill any divots on the edges to ensure it's a smooth line, and then erode it back so it fits the contour again. And we set the morph operation to actually complete these operations. And then we build. Then we do the same thing for the green blob locator. And then we're going to declare the vision portal. And the vision portal is essentially a portal that runs all the background processes for running the camera on the FTC robot, the control hub. It's going to take care of everything that you need to do, but I'll explain how to do regions later. Then we're going to run the op mode, which is again built into the linear op mode function that we're using here from the FTC SDK. So first, we're going to initiate we're going to build our portal. Here we add these processors that we created earlier, the purple locator and the green locator. Set the camera resolution. This camera we created up here as the webcam name, and you would initiate this as to your hardware map.get and then your webcam name.class, and then you would put whatever you called your camera there. Now we need to get every frame. We do while op mode is active. We're going to reset all the areas per region. So we're going to state these to 0 because after every frame occurs, we want to reset our areas to 0 so we don't start accumulating areas over as our camera keeps running. Then we'll get the blob list from the locators so we can get a list, Java list of all these blobs. A blob is essentially just like a literal blob, imagine on the screen. Then if we want to debug, ensure we can get the list lengths for green and purple artifacts, dot size. If in case you're not detecting anything, you can troubleshoot through this. Then we'll do some criteria. we want to filter these blobs by size so we can filter out small blobs and very large blobs. And then during our testing, we found that evaluating blobs by circularity meant a group of artifacts wasn't going through, and you can do this in this code here in situations where you're sure you want to detect a circle and filter by circularity. Then we want to figure out how to detect and find the physical location of the most amount of artifacts that are near the robot. So let's iterate through the blob list and figure out where it's on the screen and how big it is. That's how we do this. We figure out circularity, radius, the int x and y, which are the locations, and then the area by doing pi r squared. Then we're going to find the max area by doing biggest blob per area of the purple blobs, and then max out with the current one. Then we're going to check if the x position is less than the left bound. We're going to set the 0th region to the max between these two, and then do that for the middle, right, and else, which is always all the way on the right. Then you repeat this for the green blob, and finally we're going to make four variables from 0 to 3 regions, and you're going to accumulate the areas between the purple and the green. Then we're going to make a variable called region. We're going to reset region to 0 and make a max variable. And then here we're going to do some comparison. We're going to check if we're going to set the first region as the max. We're going to check if the next region is greater than this, and if it is, then we set the region to the first one, and then we change the new max to that region. And then we again check if the second region is greater than this max. Do the same thing. Third region is greater than this max. This ensures that the region is never going to be set as -1, and is always going to work for any region, any amount of accumulation. And finally, we're going to check if both of them are empty, we're not detecting anything, set region to -1, indicating that we don't see any blobs on the screen. And finally, if you want to actually access the loading region, you're going to do get loading region and return the region from our code. This is how Vision generally works for us. This is our pipeline, and I hope this helped.